Yesterday we started talking about pathogens and transmission. That's chapter 12, disease and immunity. And we went over some key terms. So a pathogen is a disease causing microorganism. A transmissible disease is one in which the pathogen can be passed from one host to the next. A host is the organism that is infected by the pathogen and ends up showing up symptoms of the disease. A carrier is an individual that has the pathogen in the body but is not infected, can be infected, can be diseased but is not. And because they have the pathogen in their body, they can transmit the disease to a new host. A vector is an organism, a non-human organism that carries the pathogen from one host to the other. The vector itself cannot get the disease. So that is a difference between a carrier and a vector, right? The carrier is from among the host population, possibly, right? The vector is a non-human, right? It could be an insect, it could be an animal, depending on the pathogen, and it does not get the disease, but only carries it, transfers it from one host to the next. Then we talked about the different kind of microorganisms and the types of infections they cause. So we talked about bacteria. They produce toxins in the body of the host, which obviously disturbs the internal working of the organism. An example is cholera, which is highlighted by severe water loss, right? So diarrhea and dehydration. You've got fungal infections such as athlete's foot, viruses such as causing influenza, or obviously more serious infections such as the AIDS actually, not HIV. And then you've got protozoa causing malaria. And it's not only for humans but other animals and plants as well. So an example of viruses causing disease in plants is the tobacco mosaic virus that infects tomato and tobacco plants. And then there's the bracket fungus, which grows on trees and eats it up from the inside. Then we talked about resistance. Pathogens can become resistant to treatment, medical treatment, and so that medicine is no longer effective in controlling and killing them. Today we'll start talking about from the point, right? Transmission. So there are a number of ways pathogens and thereby the diseases that they cause can be transmitted. The first is direct contact. The direct contact occurs mainly through the blood or other body fluids. An example of a disease that is transmitted this way is AIDS, which stands for acquired immunodeficiency syndrome. And it is caused by HIV, which is the human immunodeficiency virus. So HIV is the short form for the full name of the virus. AIDS is the condition that it causes. It's called a syndrome because it is not just one disease, but multiple diseases that that right the host is infected with because of compromised immune system. So we'll
Sir, your
talk
mic
about
is
that.
mute.
We'll talk about that. Okay. So a bit of technical difficulty there, but right. So the human immunodeficiency virus that causes AIDS can be transmitted uh, through, for example, infected needles. So infected needles, for example, being used by drug addicts who are sharing needles, right? Or, unsafe practices in clinics. It still happens in the world, right? So clinics or hospitals or anywhere where needles are being used. And so the first time the needle is used, obviously it has some blood on it. If it is reused and a second person injects him or herself, then there's a chance of getting the virus if the first person is infected, right? So contamination. Okay. And so obviously, right, even in hospitals, the equipment is very uh, carefully sanitized, and care must be taken that nothing contaminates the patient and nothing of the patient, for example, when during surgeries, right? Nothing from the patient contaminates the doctors or nurses. Yeah.
Yes.
No blood or any other bodily fluid, because especially, right, if there is like the pathogen present, then it's going to be problematic. Another uh, mode of transmission is, I would say, promiscuous activity. So, right, so when a person has more than one partners. Now, I say it this way because, right, it tends to show up this way. What the book says, they use the term unprotected uh, sex. And, you know, if I stick at this point, if I just stick to the syllabus and say, oh, well, that's what it is, I find this, sort of subliminal messaging that as long as you use, when you say it this way, that means that as long as you use protection, it's okay whatever you do. And maybe in some parts of the world it is, although even those parts of the world, such kind of activities are not looked on favorably by people who understand, right? And people who don't care, then it doesn't matter. Of course, using protection is good even in valid cases where perhaps during marriage or whatever. But the point is, right, even though this is a science subject, it's biology, the way something's presented has an impact. So instead of saying it used to be that way in the older texts, I believe, right, that promiscuity was highlighted, and that is where it really shows up. uh, I might be speaking from a position of lack of information or ignorance perhaps, but uh, I have yet to hear of a couple who have been faithful to each other throughout marriage, and have not engaged in these kind of extramarital engagements that have ended up with AIDS just because of these activities, not from some other infected needles or contamination or something like that. So, on a side note, just to highlight that, right? And also, finally, as far as direct contact is,
And like what is AIDS?
huh?
And what is like AIDS?
We'll talk about AIDS in a bit more detail later on, but AIDS is the condition that the human immunodeficiency virus, the HIV, causes, right? So it weakens your immune system, and because of that, the patient in this case uh, keeps getting infected by various pathogens and has various infections and diseases, and even what would be a slight disease, for example the common cold, becomes very exaggerated. Why? Because the immune system isn't working properly. Okay, and that's why it's called a syndrome, right? It's not, because AIDS is not one disease. It's not like characterized by okay, only this can happen. No, you can have any number of diseases infect, like pathogens infect you, and any number of diseases at the same time. So okay, and does that answer your question?
Yes.
Okay. As far as AIDS is concerned, uh, right, saliva is considered very low risk. For HIV transmission. Next up, we have indirect transmission.
And like can a person get AIDS and HIV together?
Again,
I
to clarify, HIV is what the virus is called, the pathogen. AIDS is the condition that the disease condition that is caused by HIV. So they're not like, they are two different things, in the sense that HIV is the name of the pathogen, the human immunodeficiency virus. That's what the V is, and it causes AIDS. So the condition it causes is called AIDS. Okay. All right. So indirect contact, right, and this is basically, right, getting the pathogen via contaminated surfaces, right? So for example, you are handling raw meat, and you put it on a cutting board and you cut it up and whatever, and then without cleaning the cutting board, right, you chop vegetables on that thing, right, and so the vegetables become contaminated with whatever them. So you may, right, wash the meat later, so the meat's okay, but the cutting board was contaminated, right, and then you chop vegetables on the contaminated cutting board, and so and you put them directly into your food, or you make a salad out of them, for example. And so, right, that can happen. Or you, right, so you eat them raw, or what you call it, uh, you uh, right, eat the vegetables without cleaning them, right, and so food poisoning can happen, right, and in some cases can be very severe. Then right, modes of transmission that come under indirect, the scenarios that come under indirect transmission are, airborne, droplet, or aerosol infections. So, right, the pathogens that are present in the air, aerosol or droplets. And so, an example of this clearly is when you go around, right, you have the cold or the flu, and right, or even when you're like sneezing and coughing and maybe even laughing, what happens is, right, there's a fine spray of, you know, for example, if you laugh, then a fine spray of saliva perhaps, right, suspended in the air for quite a bit of time, because they're very fine droplets in the air, and so they don't immediately fall to the ground. And if, for example, right, or you sneezed or you coughed, and especially the sneezing part, right, there's an image in the book that shows, right, the area of impact, and like when a person sneezes, right, all the particles that come out that perhaps we can't see, right, and then obviously that spreads everywhere, and that gets on surfaces, and so this stays suspended in air with the pathogen, right? So if it's a bacterial or viral infection, and so when someone else breathes that in or touches it, right, or somehow comes in contact with it in a way that can, they can end up getting infected. Okay, so when the droplet, however, evaporates, so which is going to take some time, but when that happens, right, if it's a bacteria, it will dry out, and when it dries out, it will die. In case of a virus, right, it can stay suspended, so it can remain floating in the air and infectious for a very long time. And so obviously the more crowded the place is, or even at home, if you're not careful, right, there's going to be a lot of uh, contamination of surfaces, and I mean, you've got microorganisms anywhere, right? The cleanest surfaces have microorganisms, but then the point is that we take care as much as we can, especially people who are suffering from some sort, even if it's the common cold, right? You take care. uh then I'm not writing this on the board, but they have a section where they're talking about contamination by houseflies, and houseflies seem harmless, but right, they talk about the fact that houseflies go and sit everywhere, and they sit on dirty places as well, and so their feet and mouths and wings and body and everything, they're covered with, bacteria and other pathogens, possibly when they come and sit on our food or on our things, and so they transfer those bacterias, or those microorganisms, not just bacteria, and that could be a source of transmission, right? Now, we
Like
have,
that also affects our immune system.
huh?
This- Like if we get a flu, like it was because that our immune system was affected by a bacteria or a virus.
Not the immune system, right? So different pathogens have different modes of action. They infect you and cause the disease in different ways. The HIV directly acts on, it weakens your immune system. So that is a, there are certain cases where the pathogen affects the immune system directly. In the case of the common cold, it's not directly affecting your immune system. And the evidence for that is, so it affects your respiratory passages, right? Your nose, your throat, your lungs, perhaps, if it's pretty bad. And so you get the runny nose and the sore throat and everything. So that's what it infects, whether it's bacterial or viral. And if you actually leave it, it takes about a week or so, depending on how good your immune system and how bad the infection is. You will recover it from it. And especially if it's viral, there is no medicine, right? So there is no medicine to cure viral infections. I mean, there are antivirals nowadays, but not there. That's a separate thing in it. So, right, and we're going to talk about medicine later on, so antibiotics and everything. And so it takes a bit of time for the immune system to get going. That's why it takes about 4 or 5 days, a week, for the symptoms of the flu to die down and go back to things to go back to normal. So the flu, as you asked, does not affect the immune system. It affects your respiratory pathway passages. Okay.
Yes.
Okay, now defense against pathogens. Right, and we have, first of all, mechanical barriers in our body, and these obviously include the skin, first of all. So that is a very important barrier that prevents the access of pathogens to the inside of our body, right? Other than that, there are the hair in the nose, and they trap particles in the air and pathogens as well, and so they don't allow them access to the inner parts of our body, right? If the skin is cut, obviously, if you got a cut, especially if it's a deep cut and you got sand on it or something else on it, right, then the risk of infection is higher, because the you know pathogen may have gained access to your bloodstream and is going over your all over your body, possibly. Okay. Now, hair in the nose, right? So obviously, there are no hair in your mouth, and so if you breathe through your mouth, then uh, if there are pathogens in the air, then they can possibly get unhindered access to your lungs, right? Or at least your throat. Then there are chemical barriers, and these include the acid in the stomach. And so normally, right, any microorganisms that reach the stomach will be digested due to the acidic conditions, and so they won't survive to get into the blood if they've gone there by mouth, obviously. And as I said, right, everything, the cleanest surface that you can pick has microorganisms on it, and so we are exposed to them. I won't put a number to it, but we're exposed to them everywhere throughout the day, even on the food we eat, as clean as it may be. And if we did not have these defenses, we would be falling ill all the time. But the majority of microorganisms that do get inside our body, right, are taken care of by the mechanical defenses, right? Either they don't get in, or if they get in, right, perhaps they're digested in the stomach and can't go forward, or they're trapped in the hair in the nose. And as far as your respiratory passage is concerned, there's also the mucus that is produced in the trachea and the bronchi. Now, I don't know why they mentioned this as a chemical barrier. It is very much a physical barrier, but sure, okay, fine, that's how they're saying it, I guess. So remember we talked about the goblet cells and the ciliated cells, and the mucus being swept upwards and then into the esophagus, and then into the stomach. And so that is a chemical in like they're terming it as a chemical barrier. And so, right, microorganisms can get trapped in the mucus, and so they are prevented from access to your lungs and beyond. Any
Like, can our skin barrier get damaged?
can our what?
Skin barrier.
Well, yes, cuts, scrapes, bruises, anything that removes the skin and exposes the blood vessels. Right, the skin is rather thick. It has four or so layers. It is thick, obviously, in relative terms to everything else. Right, all the other layers of your body. So, right, if there's any form of damage to the skin that exposes blood, then yes, right, you can get infected.
Okay.
Now, with that, now we talk about certain diseases, and I will sort of skim over them because there's just a lot of detail and a lot of repetition as well, right? So I'll try and talk about the major points, and then we can I'll leave the reading to you, let's say. Does that work? Yes? No? Okay, so we're going to start talking about mosquitoes and malaria.
Yeah, that is fine.
Now, a very good thing is the life cycle of the mosquito, right? From the larvae growing up to infection and etc. etc. It used to be part of the syllabus. It no longer is. So, right, the parasite for malaria, right? And parasite is any organism that takes benefit from another while causing harm to the host. Now, this is not very like proper scientific. I have just explained it. So, how is it a parasite? Right, because it's going to go into your body, it's going to replicate, it's going to use up the nutrients and the machinery of your cells to make more of itself. So it's benefiting from you, but it's going to end up destroying your blood cells and causing harm to your body. And so that's what a parasite is. It benefits from the host while causing harm to the host. And so the parasite for malaria is a protozoa, called, right, plasmodium. All right, and the mosquitoes involved are the Anopheles, and the ones that are actually involved in the malaria transmission, right, are females. So male mosquitoes, right, they actually feed off nectar from flowers. So it's the females that are transmitting. And in this case, right, these guys are called vectors, as I mentioned. So they, when they bite a person who perhaps has the uh, plasmodium, and they uh, drink its blood, then the plasmodium goes into the mosquito stomach where it stays and it sort of grows, and the mosquito is not infected with malaria, right, even though it has it in its body. Then when it goes and bites another person who may or may not have the malarial parasite, then the parasite goes from the mosquito stomach, from its body, into the body of the new host, right? And that person ends up getting infected. Okay.
Yes.
All right. So, right, they go on and mention the areas of the world where, and the number of countries, the number of people who are infected, etc., etc. Right. Uh, so what happens is that the parasite, right, once it gets into the body, the parasite goes to the liver, and there, right, it will infect liver cells and reproduce. So obviously it's going to cause harm to the liver. From there, the new plasmodium, the protozoa, they break out of the cells in the liver and go to the red blood cells. So they infect the red blood cells. And from there, uh, they stay in like the reproductive phase in the red blood cells for about 2 to 3 days, and then they break out of the red blood cells as well. Now what happens is they're causing damage to your red blood cells. And so one thing that you're going to notice, right, a symptom of malaria are chills. Why are you going to feel chills? Because RBCs carry heat. And so when your RBCs are dying, they're less around to carry heat. And so when the plasmodium does that, right, you get the chills and shivering, right? And this is followed by fevers, right? And then profuse sweating. And so if it is not treated, among other things, the patient will become anemic, right? Which means they've got low hemoglobin. And the reason they've got low hemoglobin is because they've lost the red blood cells, right? And that means their oxygen carrying capacity and all the heat carrying capacity, all of that is compromised. Now then, talk about the control of malaria. And there's no uh, medicine to attack the protozoa, but what they do have are like preventive measures, like for example using mosquito nets, simply not traveling to countries where malaria is prevalent. And then there are certain treatments, so there are certain medicines, so to speak, that can be taken that are called prophylactic, which basically are preventive, right? So what they do is that they affect the life cycle, right? And they kill the parasite, the plasmodium, as soon as it's injected into the host body. Right, so if it's season for malaria in a place where we live, or we're going to another place where there might be like the risk of infection with malaria, then right, people take these prophylactic treatments to be safe, that if a mosquito bites and it does have the plasmodium parasite, then as soon as it gets into our body, it will be killed off. Now, right, the most effective control is, you know, based on the elimination of the mosquitoes themselves and getting rid of their eggs. So their eggs grow in water. So any water body is right somewhere that mosquitoes can lay their eggs and where the larvae can grow. And so that is sprayed with oil. And so what happens is that the larvae suffocate. They can't get air, right? And obviously that ends up
What
killing
is
them.
Malaria?
Larvae are like the initial stage of growth of the mosquito, right? So it's sort of like a small worm type thing. It hasn't developed into a full mosquito yet.
Okay.
So it can be sprayed with oil or insecticides as well to kill them, the mosquitoes or the larvae. So bodies of water can be sprayed, or regions where there are lots of mosquitoes, right? Those can be sprayed. DDT used to be used, but it's very toxic, and so that's not used as much anymore. DDT is a chemical. Okay. Uh, so mosquito breeding grounds are being removed again, right? So stagnant water, one thing is spraying the water with oil and insecticide, right? And others are removing stagnant. So stagnant means water that is just standing; it's not flowing, right? So puddles or something, large pools of water that are not flowing. And new scientific approaches are trying to make mosquitoes that have sterile males. That means the males cannot reproduce, or females that are flightless. In both cases, right, they're not going to survive, because if the mosquito can't fly, then obviously it's going to affect its life cycle. And that's all we have about the mosquito. Any questions?
No.
Now, if you have a few minutes, right, we can
I
continue.
want to ask,
Huh?
like, in how many days can like malaria can be cured?
How long does it take for malaria to be cured? Well, I mean, uh, let me look that up. How long does it take for malaria? 7 to 10 days with treatment. With treatment. So this is not a case which is going away on its own, apparently. And severe cases or delayed treatment can, be extend to the recovery can extend to 2 to 3 weeks or more. Okay.
And like it is said now that in malaria you get fever after in the evening or after evening.
Uh, I don't like. I don't think that's for malaria. You get a fever whenever, right? I mean, it's followed by the shivering, which is whenever the malaria is growing and damaging your red blood cells. So there are certain ailments, I believe, such as typhoid, perhaps, where you get fevers at a certain time of the day.
Okay.
I'm not sure about malaria though. Anything else?
Mm.
Okay, so do you want to continue and we can talk about HIV?
Okay. Mhm.
Now, interestingly, we've already talked about HIV, right? Whatever we said earlier, that's pretty much all there is to know about it. Uh, like I said, there are other details that can be read from the book. Prevention is basically right through education and so educating people about. I'm just going verbally over here. So educating people, or if I can show you the book about what HIV is, the dangers of HIV, and not to use contaminated needles, and obviously to practice, you know, safe procedures. Let's say, right? They've got these details over here when it first appeared and stuff like that, right? And the percentage infection in regions and all of that. So, right, you can do that. So, yeah, there are a range of drugs available today that can be used to treat or, in fact, control HIV if a person, like AIDS, if a person is infected, and right, improve their quality of life. So they say over here that the best way to avoid HIV infection is to avoid having sexual intercourse with an infected person. Again, right, I already gone over that. Phrasing is inappropriate, right? And I've mentioned why. Uh, the good thing is they mention over here the disease is avoided by not having sexual intercourse with a person who might have the disease. This is a good reason, among many others, for being faithful to one partner. So that's a good thing they mentioned that. Right? Using physical barriers for both men and women. So that is obviously, a protective measure. And if a person suspects that they might have HIV, then they can refrain and seek treatment and right go through that. So preventing the spread. If a person does have HIV, right, and so the test checks for antibodies against the virus. It doesn't check for the virus itself, but it checks whether the immune system is trying to work against it. So they check for antibodies against the virus, and if those are found, then the person is said to be HIV positive. Okay.
Like a person can HIV over time, or like they can be born with it. Born with it.
They can be born with it in the case that their mother had HIV, right? And getting HIV over time, so that would be the case that, as I mentioned, the person could be a carrier, they might be infected, but the symptoms are not showing up. And then sometime along the line, right, the virus becomes active and the symptoms start showing up. So they did have the virus for a long time in their body, but it just was not causing the disease, it was not causing any symptoms.
Okay.
All right, the last thing on our list for this one is cholera and hygiene. I'll leave that for next time, and after which we'll start talking about other, you know, things that can go wrong or we can, mess up our bodies by consumption of alcohol or smoking and stuff like that. Yeah, leave that for next time. Anything about today's lesson? Any questions?
Hmm.
Okay, so I'll see you next time, inshallah.
Inshallah. Allah Hafiz.
Allah.